So now just to introduce our next speaker, so Dr. Harun Chowdhury, and we know all Harun is behind this and working hard to kind of facilitate all these activities, particularly technology side. I didn't know anything until this morning. So Dr. Harun Chowdhury is a renowned expert in the field of aerodynamics with a focus on various areas such as road vehicles, trains, and wind turbines, turbo machinery, and buildings and sports. He is also well versed in conventional and renewable energy, engineering education, curriculum design, quality assurance, and accreditation. Over 20 years experience in research and academic area. He has worked as an experimental aerodynamicist and a mechanical system design engineer. And additionally, obviously, he's running the ASEP, which is the Australian Society of Energy and Power, and running various conferences. And he's the kind of, I would say, key person behind that running these conferences. So without further, I would like to hand over to Harun to give his presentation. So thank you, Harun.
Thank you, everybody. And also thank you, Dr. Naushad Haq, for his introduction to the audience. And today, I'm here to give the inspiration to the young engineers who will be, who has also presentation today at the later session. But this is like related to their presentation, and also it is related to Professor Hu's presentation as well. It is about very fascinating technology that is biomimicry. So I'll be talking about the biomimicry, and I'm since morning. So I have few current affiliations. I'm a research fellow at this moment. I'm working on a project, government-funded project on turbo machinery design, and with the industry partner and federal government funded. And also I'm the vice president of Australian Society of Energy and Power. And we organize conferences, and also Professor Firuz is the president, and he said that we can introduce some of the courses. Maybe in future we have planned for short courses like LCA, the cutting edge software, tools that is focusing for job. So that is our future agenda. And also, I'm also the principal investigator of ABSCUBE Engineering and Education, and that is a research commercialization of, and I'm working here as a principal investigator. Now, currently, I'm supervising some of the project, our project development team I'm leading. One of our projects is bioengineering sector, that is a bio arm, and we have some prototypes. We already developed a few prototypes, and another one is a body-powered prosthetic arm. It is focusing on very low cost solution for people who has no, who has no capacity to go for a high cost solution for body arm. So we are developing some kind of low cost solution for those people. And another one is a turbo machinery design, like a small solar, not solar, is a rooftop wind generator. And we have already done 2 prototypes, and we are working on making a little bit of more testing to make a product, and we are working on that commercialization as well. And another one is we are also creating some kind of robotic, because this is to education, our future generation, especially the educational type of project, so that they can make their own, they can program their own things. And it is a solution for 3D printing, designed to 3D printing to program. So this is for, we are designing a curriculum-based, project-based learning system for focusing. So this is a project we are running. Another one is the gardening system we can introduce some dry gardening system. We have come up with some prototype solution, but we just need to make a real prototype to.
And finally, the energy efficient biomimicry road vehicle. Today I'm going to talk about this energy efficient biomimicry road vehicle, the product we are currently in progress in our company. Now, what is biomimicry? So here you can see some of the engineering vehicles. One is an aeroplane, and the one is a train, and the last one is a submarine, underwater vehicle. So you can see the shape of the airbus. It was inspired by an animal, is dolphin, and also the beak of this kingfisher is the inspiration of these high-speed train, bullet train, and the whale is the inspiration of this submarine. You can see the similarities of this engineering design with the design of the nature. So when we're copying these things from the nature to design engineering applications, that is called the mimicking, biomimicry in the engineering design. Now, what is the methodology? Now, first of all, we need to determine our design objectives. That means what type of design we are going to implement. For example, car, bus, or any other objective, any other engineering application. And then once we know our objectives, selection of a suitable biological species. So where we need, similar to that previous examples, like a dolphin or any other species like whale. So we need to find out what is the matching for that, our design objective. And once we get our inspiration, the biological species, we are going to select that species for detailed study for the parameters. And we need to identify what are the parameters that we can implement in our conceptual design. And once we know our conceptual design parameters, we then optimize this design, and then once this optimization is done using CFD, an analytical method, we need to make a prototype of this model for a physical testing. And once the performance is tested, and if there is any further optimization required, we need to again go back for analytical design and then making the prototype and test until the optimization is satisfactory. Now for this study, the design objective is to design energy efficient road vehicles. And there are several types of road vehicles we have selected for this study. And we are designing a passenger car and a light truck, biomimicry light truck and biomimicry design for a passenger car. Now, before we go for the biomimicry design, we just need to see back the evaluation of passenger car design. So these are the basic car design. Initially, when the vehicle was introduced, passenger car was introduced to the human civilization, 1880s. Second Marcus car, it's the basic mechanisms are there. There is no aerodynamic fairing, nothing is there. And this, once the time passes by 1920s model, there is a shade and there is a fairing there. And then in 1960s, the more aerodynamic car coming into play, and you can see the Toyota Corolla model. We know our objective. Now we are going to select a suitable biomimicry biological species for our biomimicking project. So our objective is to make a car, passenger car, and we just need to look at some, investigate some of the species in the, anywhere in the world, and look at the features, and we found that the yellow spotted boxfish is a very suitable biological species for car design, because it has a box type shapes, and also it has curvatures, and all other features are really promising for designing a low drag, energy efficient biomimicry car. Now in this slide, a little bit of an swimming video of a boxfish. Here you can see the size of the fish is very tiny, but you can see in this video clip the different orientation and movement, and how it is moving along and swimming underwater, the features and all other things. And this is a really good selection for designing our passenger car. Now we know our species, and we know what actually our objective design is by passenger car. And the conventional design, we are going to redesign the features of the conventional car to make our biological design. Now in this slide, I'm going to show you the methodology that we applied for this study. So first of all, we collected the sample of a boxfish, live boxfish, and then we 3D scan the boxfish to get the exact features of the boxfish, and then we took all the measurement, and then we make a 3D model of this boxfish for further study. And then through the CNC manufacturing, we created a quarter model boxfish shape for study. Now for this study, initially we develop a shaped model, and then you can see some of the study related materials. We took a mesh, and then we created a model wind tunnel, and we evaluated the performance, drag, and features of this, and you can see some of the evaluation. And then the wind tunnel experiment. In this experiment, we used a load sensor to measure the exact amount of drag and lift and all other forces in the wind tunnel. So you can see the wind tunnel test section. Type wind tunnel, so we can
test, it's a full car inside this wind tunnel. And this wind tunnel, some of my student, he was doing this, testing at that time. So this is the outside. So now this is the box fish model. And now from this box fish, what we're going to do, we are going to, like, this was our inspiration. We're going to take that model, this one, and we stop from, these are the features. Okay, these are the, so we're not taking the tail, because if we put a tail, in a car, so it will be like a fun. So we're not going to make a funny things. Okay, so we're going to make a, but this is a, we saw that this is a, the tail has very, very good advantage, but we cannot do it, put a tail, in a car, and it will be like a funny thing. So now, this is our inspiration, where we have applied our modeling. So this is the car we come up with, the iteration, with modeling and all those things. It is not that like a click of a button or AI will generate these things. We are human AI, human intelligence was applied to these things. Okay, so this is the creativity of a human being. So this car, you can see this one, this is our model, and we develop this model car, and then we go for the optimization. So it is not the final version. We optimize these things. This is still a virtual world. And this one, we test it, and if it is not okay, what we do? We just crash it and throw it and do it again. So how many times, you can ask, how many times? Maybe hundreds, more than 100 times we have done these things. So it is a time-consuming thing. It is, and once we have we have to stop somewhere. Okay, so we just compare, and then, okay, stop. We are running out of time, so go for the next stage. So next stage is fabrication, and this is a fabrication process is going on here in RMIT, and it is a teamwork. It is not that Dr. Harun has done everything, because I run a team, and this team is, we work together, and this video is, we created this video with the RMIT media cell. Actually, this is very slow correction, that's why this is not showing everything nicely, but it's available online. So this one is a teamwork, and we build up our teamwork to make this kind of a small model even requires a lot of devotion of the students. And that's why I want to inspire the student, because the fish inspired us, and I want to inspire the students so that they can in the future they can go on with their innovation. Now this is our the constructed model, and then after that we painted it, and we just you can see this is the wind tunnel test section, and we are doing some the real test, this is a quarter model. So if we just multiply it's a quarter model, that means it's not that small size. So this is also we compared with, we have a Holden project beforehand. Professor Firoz Alam was doing some tests, and Professor Simon Watkins was doing this kind of research, and we still using that model, and that model costs like $50,000, more than a a car. And this model we use, it's a detailed model, so we use this to comparison, how much it is compared to our model. So we compared these both models, and on top of that, we have we also model sedan model, and also hatchback and minivan, and with our biomimicry. So this, the fourth one, is our model. So we compared with this one in a a safety comparison as well. So look at that, how does it compare? So this is the safety work. You can see some of this work, and I'm just going to. Without going detail in the results, I'm going to show you the final version. So what is that? The box fish with the tail. It gives us the significantly low product. Look at that, 0.16. And because you see, it has tail feature is also and then if we go for hatchback, this hatchback model has 28, 0.28, So this is compared to that is a little significant, like higher, but so this one is our another, like the model test we have done for the comparison, like a Sedan one, and Sedan one is similar to Holden Commodore, and this one is a minivan. It is a Toyota model. So this has although it has a bigger, like looking like a box. Go through this one. This model is like you can see the frontal edge. So we have few more data, volume, because we are going to compare model to model. So how it is comparing the volume element. So volume, you can see the largest volume for this model, and then this one 1.4, double the volume of Sedan, and it has 0.23. So this is because of the feature of the the box pitch. So naturally, like it is coming up. So this model, actually we are happy with this one, and then we applied this to another design. It is like light truck. So for the light truck, you see this light truck is conventionally designed like that, the conventional design, and we have a model at RMIT University. And the biomimicry, we come up with this, the principle of biomimicry. You can see the front shape. We change this to make it more streamlined. So this design, we go through the same principles. I'm not going to explain all those results, but you can see some of these results are here. And this is the model inside the wind tunnel. And what we have come up with is we got the reduction of the drag, the conventional design, 0.6 drag, whereas with this, our not conventional, it should be like our biomimicry design, this one is 0.4. So this is a 30% reduction. So 30% reduction, you just think about, you just compare that drag is fuel. So it's a fuel saving. So if you can save this much fuel, it will be like a significant achievement for us. Now this is like not the full scale. We have where it is not that we have developed this commercial vehicle, so it's a long time to go, but it is a shape we come up with. The conclusion is like 50 up to, our study shows up to 50% drag reduction is actually possible. We got it, and it will it's a reduction. As I said, that if we reduct, if there is any reduction in aerodynamic drag, that is a reduction of fuel saving, and it will give us energy saving as well, security. Now, what's the next? So what the next? You can see this is the toy model in our lab. We just created a 3D printed toy model, and to see the aesthetics, because we of course we need to see first the vehicle, how does it, what's the the color, and what is the shape. So we just need to look at the aesthetics of the view of the car, and that is very important. So we are coming out with some design, and we are we are recruiting people, intern. They are also taking part into this project, because it started 2016 at RMIT University. We started this project, and it is still going on. And this is the final version. We are focusing on the full scale shape, and now this is our project is going on underway. And also we did all publications in with my friend in NASA. They have a project with biomimicry of space, a book chapter. I put a book chapter up there, and these are all journal papers. And this is our team, and this is the team member. They significantly contributed, but these are all other team members, intern for a couple of months or couple of 3 to 6 months. They contributed their contribution. If they are related to a publication, we also give them the credit. And also special thanks to Professor Firoz Alam, because he's always giving us inspiration. It is not only the fish, okay? And you need someone to, of course, you have to give some inspiration. So inspiration was coming from Firoz Alam as well, and still, he inspires all the time. Not only Firoz Alam, also like Dr. Nashad Haq and Professor Kamra Alam. He is my elder, inspiration people. So they are inspiring, and I'm going to inspire you people so that you can move forward and you can contribute in the future. And also, if you have any question or anything, feel free to contact me. My email address is available online. And thank you for your time.
Thank you, Dr. Harun. It's a nice presentation, and interesting that everybody should inspire everybody, and that's how we do good science. So I think that's your own. Can someone take a photo? Who is that? Saad?
Who is the photographer?
Okay. So anyway,